Good afternoon, my YouTube viewers. It is Crystal here. I wanted to make another video for you. You may have seen the video that I made this morning. And in the video that I made this morning, I was giving you code concerning the O-rings and the Space Shuttle Challenger in R and also Python. But I did some thinking about it, and I decided that in this Python code, I wanted to include stats models. The reason why is because stats models was written similar to R, and I think that that's what they did whenever they made stats models. They wanted it to resemble R because R is a statistical programming language and stats models is a statistical library in Python. And actually, stats models originally had been a section in SciPy, but they had decided to make stats model its own library. So that's what we're going to talk about in this particular video. We're going to talk about the Space Shuttle Challenger and how the O-rings were damaged. Right, basically what happened was when the temperatures were low, the O-rings would be damaged, and the reason why is because the O-rings were made out of plastic, and when the temperatures were low, it would harden the O-rings and they wouldn't be able to do the job that they were supposed to do, which caused them to be damaged, and that is what caused the disaster of the Space Shuttle Challenger. And what we're going to do is we're going to compare the temperature to the O-ring damage and make a visualization of that. And so we can prove statistically that as the temperature decreases, the damage to the O-rings increases. So you needed to have a higher temperature, which I find that a bit unusual because in my past life in the military, I worked on electronics equipment, and they had to keep the electronics equipment cool because if it wasn't cool, it wouldn't work properly. But with the space shuttle, you had to it had to be launched when it was warm because if it wasn't warm, then the O-rings would be damaged. So we're going to do this code review. We're going to use statsmodels, which is a Python library which had originally been a part of SciPy. So in order to do the analysis, we need to import the libraries first. You always import the libraries at the beginning of the program, which is different from R because R, all of these functions are built into R. So you don't have to import any libraries into R for this particular problem. But with Python, you do have to import libraries. So we're importing pandas to create the data frame, NumPy to perform numerical computations, and we're going to import stats models, which is the statistical portion of the program, and we're going to import matplotlib as for visualization. We're also going to import sklearn for another part of the program, but that's not what this video is all about. This video is about stats models. So the first thing that we're going to do is you could, if you can find a CSV file, you can import the CSV file, but I could not find a CSV file that did what I wanted it to do. And so I'm taking a Bayesian statistics course on YouTube, and since it's a small data set, it only has 23 rows by 2 columns. Since I couldn't actually find a CSV file on the internet to do what I wanted it to do, I just made a file. And I did that because I just copied the data from the Bayesian statistics course, and I had to write it out by hand and then type it by hand. But since it's not a big data set, it wasn't that time consuming. So O ring equals temp, and then we've got all the temperatures for the temp, and then it equals damage, and then we've got the number of O-rings that were damaged. And then we're going to turn it into a data frame using pandas. And here is your data frame. So you've got your temp and your damage. It had 23 launches. And so next what we're going to do is we're going to define our x and our y variables. The x variable is the temp, and the y variable is the O-ring damage. And now what we're going to do is we're going to use stats models, and in stats models we're going to use the OLS function, which is least squares. It's the least squares method, and it's going to be y and x is going to be what you're going to use a linear regression, and then you're going to fit it. And then so we're going to print the summary, so you can see that this is the summary that has been printed out. The dependent variable is going to be damaged. The model is going to be OLS, and the LS stands for least squares, and I don't remember what O stands for. Method, least squares, and then I did it today. Did it this morning. It had 23 observations, so that was 23 rows of data. Degree of freedom residuals equals 22, and the degree of freedom of the model equals 1, because the degree of freedom is generally the number of columns minus 1, but it really depends upon what model you're using as to what the degree of freedom is, because depending upon the distribution that you're using, it could have a different formula for a degree of freedom. But we're just going to say in this particular instance, it's the number of columns 2 minus 1 equals 1. Covariance type is non-robust. R squared is 0.179. Adjusted R squared is 0.141. Your F statistic is 4.786. Your probability is 0.396. Your log likelihood is -55. AIC is 113.1, and BIC is 114.2. And AIC and BIC are like goodness of fit parameters. And then we go into the coefficients. So it tells you the coefficient is 0.181. Standard error is 0.008. Your t-score is 2.188, and your p-value is 0.40. And then so basically the p-value, whenever you're doing hypothesis testing, if the p-value is above 0.5, then that means that the data set is not significant. But if it is below 0.05, it means it is significant. So in hypothesis testing, our p-value indicates that it's significant because it's only 4%, whereas you need to have 5% or above to make it not significant. And talks about the omnibus is 26097. Your prob omnibus is 0. Your SKU is 2.208. Your kurtosis is 8.012. Durbin Watson is 0.918. Jockey Barra is 42.760. Prob Jockey Barra is 5.8 to the -10. And Condon number is 1. And something that I forgot to mention up here, this looks like here, it's your confidence interval. So your confidence interval at 0.025 is 001, and your confidence interval at 0.795 is 0.035. So that is your summary, your stats model summary. And then when we do the R, you can see that the summary of R is very similar to the summary of stats models. It contains a lot of the statistical information that's in stats models. But I have to say that I like stats models better with regard to the way that it produces the summary, and I like R better with regard to the fact that you don't have to import any libraries. So now what we're going to do is we're going to plot the graph. So we're going to make a scatter plot of X and Y, and then so since our X variable is two dimensions, you can see that it's 2 dimensions by looking over here because it's got 2 brackets. Our X variable is 2 dimensions and our Y variable is 1 dimension. What we have to do is we have to take our X variable and we have to convert it from 2 dimensions to 1 dimension to get it to work on the graph. So X values equals X dot I log, and then it's colon comma 0 dot values, and then it's assuming the temperature is in the first column. And we've got our temperature is in the first column, so that's good. And then AB equals N polyfit X values Y1. So polyfit is a NumPy function, and that's what gives you your straight line. And then so we're going to add a line to the best fit of the plot, plt.plot X values A times X values plus B. So that's your the formula for linear regression. And then we're going to plot the labels, and the title is the x-axis temperature, the y-axis damage, and then the plot of temperature versus damage. So you can see here, as the lower the temperature, the higher the damage, because at 55 degrees you had 11 O-rings damaged, and around 60 degrees you had 4 O-rings damaged. Around 65 degrees you had 1 O-ring damaged. Around 70 and 75 you had 4 O-rings damaged. But as a general rule, the lower the temperature, the higher the damage to the O-rings. And that's exactly what happened. If you read the blog post that I made, the blog post says that the reason why the O-rings were damaged was caused by a low temperature. So I'm not going to do the sklearn bits because I did the sklearn bits in my previous video. I'm going to stop it here because we're talking about stats models, which is what I wanted to talk about. And if you like my video, please like and subscribe. Thank you so much for watching my video, and I look forward to making more videos about technical subjects, data science subjects for you in the future.